You guys have heard this term a lot of times in the past 2 days. But have anyone actually explained what they did to achieve cost optimization? No. We had a talk by Zomato in the morning saying we saved over $1 million by moving from Datadog to building their own solution. So that is actually not cost optimization, that is cost savings. So cost optimization is performing some operations on your current infrastructure to reduce the cost on the infrastructure. So in this talk, me along with my colleague, we will be explaining you why our observability went on to such a huge scale and the techniques we perform to reduce our costs. I'm Shivdeep Nalana. I'm working as a software engineer at Gojek, and this is my my colleague Kumar Harshal.
Yeah. Hey everyone. Let's start with putting some things into context. Why we needed to perform the cost optimization in the first place, and where do we started, and how we reached where we are right now. So, anyone of you heard about Gojek previously? Okay, quite a lot. So we founded in 2015, and we scaled like a dream. So we started with a call center, which was supposed to being a bridge between the Gojek, which is kind of a Rapido drivers, and customers. So we found out that most of the time we were not able to do it properly. So the people were waiting, the Gojeks were waiting, and there was the number of hours being wasted on the waiting was large. So we tried to come up with an application which was kind of Rapido, but way before that, and it was just a bridge which was connecting both of them perfectly. So what we are right now, a decacorn startup operating in 3 countries. From that one service, we scaled up to 20 services, and we have around 2 million driver partners, 190 million users, which are using all of the time. Next slide. Yeah, so that's the context, and so what we do in order to achieve this, what our team, which we call Lens, have done to Gojek, or how do we contribute to Gojek. So we are the folks who make sure that the right alarm goes at the right time to the right person, so that people don't miss out on the things that has to be taken care of, and they have the proper visibility of the stuff that is required to have their day-to-day operations. So how do we grew? So we started with basic Datadog clients. We realized that with the scale that Gojek was going on, we realized that we need some kind of in-house solution. So we started with we just moved to the tech stack, and after that we finally zeroed down on the Lens in the current form, which is it right now. Yeah, so how it is currently looking like. We are serving around 1500 plus services, 400 plus team and sub teams, running at a throughput of 1000 QPS, uptime is 99.99, and maintaining a read latency under 500 milliseconds. To have this in context, we have like how do we achieve this numbers? So 60 nodes, that is running 1423 containers and 1060 pods. So this is the testament of what we have achieved. Cortex, Grafana itself has recognized us that the scale we are running at, and how do we, what we are doing in Lens. It is being recognized by several teams. We have a case study on Cortex and Prometheus as well, Prometheus Grafana as well. Now, the reliability efforts. So talking about how we are having the 500 millisecond of read latency and how do we have handling these throughputs sounds very good, but there is a significant reliability effort that has to be go down under the hood. So the tip of the iceberg is 99.9% uptime, but how do we achieve that? The first thing, we have up-to-date infrastructure. We have a very small team, but we put rigorous efforts be on the latest GKE versions, adapt the changes that are there in the market. Nodepool, we recently drained our CIDR and we moved to a upgraded CIDR just to make sure that nothing goes wrong with the observability team, which is serving the Gojek. We have quite a number of projects and products which we will showcase right now. So for monitoring, we have GUI, Grafana UI that supports plotting graphs, and you can query for anything using PromQL. Next slide. So how does it look like? This is a sample dashboard that we have, and we have somewhere around 700 plus dashboards across Gojek, over which you can put alerting, but we have a separate alerting dashboard as well. Go back to the, for alerting, we have an in-house developer portal which supports alerting managed via the UI. Earlier we also had the GitOps way of managing alerts, but that was not a better approach. So we adopted a UI-based approach as well. The next slide, next, yes. So it is somehow you can go to the dashboard and put the data source, whichever team you have. Like we support the multi-tenancy, so every team is a separate you can say tenant. So you can put your data source, alert name, and fill out the descriptions. You will get the alert, and this part you can see whenever you get an alert triggered, you will also have the visibility that when over the last 7 days when was the alert triggered and what was the host or whatever the information that is needed. So this is how our alerting UI looks like. The Grafana agent, we opted out to have a standardized agent throughout the Gojek. Grafana agent is currently used for metric collection. And there is GMP support in Toolens. Google Managed Prometheus is something that we have find out that contributed a lot to saving costs, because if you have stack driver running for an instance, and let's say what we have 400 teams, every 400 teams have a separate stack driver will also contribute to the cost. So what we found out, which we'll talk about further, that having a Google managed data source and getting all the data at the single UI, that we tried to zero down on Grafana as a single source of visualization tool. So everything can be visualized at Grafana only. So Google gives you the feature that you can have a GMP Google Managed Prometheus, and you can deploy a single Prometheus infrastructure there, and you can collect all the metrics that Google is emitting. Let's say you have a load balancer or API gateway. Those metrics you can also get on the single Grafana dashboard instead of going to the Google dashboards. If you have used GCP, you may know that the GCP dashboards are pretty slow. So you can have these things on the Grafana UI again, everything at the same place, because being on an incident call, you want everything to be quick. So that was the motivation there. We have a SISLO platform. So this looks like this. So what is the error budget, SLO status, and you can put the alerts over them as well. So how do we monitor our APIs? So for API monitoring, you need a clear visibility how your APIs are performing. So for this, we have built this error budgeting and the target SLO, current SLO. What it gives you the flexibility of understanding how much more error you can afford. Next slide. So this is the basic fundamentals of calculation which we do. Total error budget is equals to, let's say you have a test API, goes by /test, and you put a target SLO, what you can afford. And let's say you went with a 99 percentile request, have 100 millisecond over 30 days. So for this latency, you have a proper error budget. Like error budget is kind of what errors you can afford. Simple. Total error budget will be 1 minus compliance target, and it will be calculated in something like this. So if you have made, let's say, if over the 100 requests you have made already 2 or 3 requests, and your target was 95, then only 3 more errors you are able to handle in next 30 days. So, and there was the next slide. We also have this alerting over this. So you can also configure the alert over this that, okay, this is the way, these are the alerts over the last 10 minutes or let's say 6 hours, whatever you want, and you can get alerted via this. So yeah, go back. Go back to the front. Yeah, and API uptime dashboards, which is basically for the API, how your APIs are performing right now. So overall, these are the products which comes under the lens. So it's kind of a overall one-stop solution for observability in Gojek, which is widely adopted. Yeah, I talked about the Google Managed Prometheus. So for a better UX user experience, we integrated the visualization of Google's most of the metrics in our Grafana UI only. The user were complaining about what has to be done with the load balancer, let's say load balancer metrics or other Google metrics that they have to go to every time to the Google dashboards and get it. So we have this in our single setup, and how do we achieve it? More usual way to achieve is stack driver, which I talked about, but it would have costed us some fortune. So instead of doing that, we are just having one of the, I would say, we have exporter that is exporting all the Google's GMP metrics into our current Cortex, and we obtain it via there. So we only have to pay the small amount of querying cost that is way more cheaper than having a stack driver exporter running all the time. So yeah, that's all. This is the architecture of our Cortex backend. Not to scare you with this, just few terminologies which is going to come next. This is the remote write, where Grafana agent will be pushing to the distributor, and ingester that is mostly responsible for ingesting things. There is the Grafana dashboard component, which is getting the data from the query frontend and then querier. And this is the ruler, which is most important for routing the alerts to the alert manager, and alert manager will take care of the alerting stuff via PagerDuty or Slack, whatever you want. Yeah, that's all. So now the thing comes, like, to achieve the scale we have and the latency we operate at, we have to run a number of these components, and there comes the cost optimization, which Shivdeep is going to talk about.
Yeah, can you hear me? Okay, let me quickly go some of the problems at this scale. One of them is IP exhaustion. So we were running on a 21/21 CIDR before, but then as the number of pods increases, those IPs get exhausted, and then we have to perform a whole migration activity again to get a new subnet on that. Long rollout times, because whenever you roll out the entire infrastructure, it used to take 6 to 8 hours. We used to just sit at our laptops throughout the night. And then cardinality issues. With these many number of pods, you obviously see big metrics. Basically, each metric has a lot of labels and values. Yeah, so all this was going well. We were scaling, and the number of teams that are onboarding is going well. And suddenly one day, our manager opened the cost dashboard, and he saw the cost. We touched up to $5,000 per day. And then we realized, okay, something is wrong here. We have to do something about this. So what is the first thing that we think about? Okay, let's first look at the data that we are pushing into Lens, and then let's decide what we should do. And then, so there is something called Cortex tools, where you can see which metrics you are actually using. By actually using a metric, I mean it's either in an alert or in a dashboard. If it's not in either of them, then you are not using the metric, it's just a waste. So we built a small framework around this to let teams know what metrics they are not using. And one of our largest tenant, which was sending almost 1 million metrics per second, so they dropped to, they reduced by 70%, if you can say. Those are the unused metrics they were pushing to Lens. So this access went on for a while, and we were able to downsize our cluster, and our ingestion, the number of pods went down by 50. Next. That is one thing that we done for cost optimization. The other thing is enabling client-side compression. So what is the second big cost that we are seeing? that is interzone network egress. Everyone might be seeing, everyone running at this scale should be seeing that. So what can we do to reduce interzone network egress? Compression. You compress your data before sending it to the across the network, and then you decompress the data on the other side. So we made a couple of experiments. We had Snappy and ZZip as the solutions. Snappy was faster, but ZZip was compressing more. But it was a little CPU extensive. But still, we had a lot of CPU with us, so we went with ZZip, and it provided us 95% of compression. Next. So this is how our data looked like. So we were running around 9 GB or something, and then after enabling compression on our side, it went to around 0. something 9 GB or something. It was 95% compression. Next. So in memcaches, we could not enable compression because memcache does not support compression on their side. So what we did, so previously our workloads were talking across with memcaches, but then we deployed, in each zone we deployed a memcache so that the workloads in the same zone will talk to the same memcache. This will increase the number of memcaches we are using, but then it reduces the rest of the network egress. So completely we reduce the network egress in this case. Next. Yeah, if you can, this graph clearly shows that this much data was going across for a single region, and when we did that, everything was going from a single region. Removing unused PVC. This is a mistake that everyone does. So we scale up our systems. Most of the stateful sets have PVCs attached to it. We scale them up, and when we scale them down, we forget to remove the PVC, and it remains stale on our system, and it gets unnoticed. So we went back. So one day we saw this, and we had almost 200 orphan PVCs, and when we removed all of them, we were saving $100 per month. Next. Scale VM. So you run, if anyone who is familiar with kitchen, we run kitchen test. Kitchen test usually spins up VMs. It runs the test, and it destroys the VMs. If the test passes, what happens when the test fails, when the test panics? It just leaves the VM like that. And we need to clean it up from our side, or else these VMs are going to remain in the cluster forever. So we saw this, we deleted 60 scale VMs from our side. Cloud logging. Usually what happens, we keep on pushing logs to GCP or Azure or AWS, whatever. Whoever is using OSS solutions like Cortex or something, we don't even have control on the logs. The OSS solution itself sends logs to the GCP, and this is also a very big cost. So we should be able to control these logs. We should actually send those logs which are actually useful for workloads. I mean, if the workload is very critical and it is going down frequently, then push debug logs, or else go with info logs or warning logs. You can filter the logs with rules. There are a number of options available on the cloud itself, so you can use them. Next. PSC instead of public gateway. So when you are pushing your metrics to Cortex, so usually what we'll do, there are a number of teams on different clusters and different projects. You can't communicate if you want to communicate between projects, you do that via internet, which is also again a cost for you. But recently, I think 1 or 2 years back, Google came up with something called PSC, where if both the clusters are in the same region, you don't have to talk via internet, you can have a private secure connect. We have similar things in Azure and AWS as well. We recently implemented this, and we saw 50 to 60% reduction of cost on the client side. I mean, Grafana agent, whoever is sending the data to us. Next. Spot VMs. This we did not actually implement, but you can actually use spot VMs to deploy your workloads which are not, which are actually fault tolerant. Like those systems like jobs or something else which you don't need to be up all the time. You can deploy those systems on spot VMs, which will also reduce the cost. Next. And event-based, I think most of the people might be knowing this. Depending on the throughput, you can scale up your systems, and then depending on the throughput, you can scale down your systems. This will also reduce your CPU cost. Yep. This is something that that is happening recently. ARM-based processors are coming up, and they are actually faster than Linux processor, and they are cheaper as well. So we haven't used this, but we saw that Cortex actually have ARM-based system, so we are planning to use that in the future. Yeah. So this is the final numbers. We were at some point at $5,200 per second, per day. And we came up to $1,192 per day after all this access. And this is within a span of 3 to 4 months. So that is 75% reduction in overall cost, almost close to $1.5 million a year. 95% reduction in interzone, and most of our teams are seeing a chargeback reduction of 70% or more. Yep. Okay, like a great scholar once said, cost optimization is a journey, it's not just a sprint. Yep, if you have any questions, we can take it up now. Or else you can hit me up on my LinkedIn.